Hello everyone. Hello Sean again. I hope you enjoyed my IT-360 video. Hopefully this one is a bit better, if not way better. Um, so today I'm going to be presenting our project for IT-359. Our group name is the Legendary Beasts, and our tool is called WeaponX. WeaponX is an automated reconnaissance and enumeration framework designed to speed up the earliest stages of pen testing. So the problem we wanted to solve is that the early stages of pen testing are very, very repetitive. Every box on Hack-the-Box, starts with running scans, waiting for results, digging through results, and then trying to figure out what tools to even run next. As students doing Hack-the-Box, we spent more time actually like parsing the data than actually learning. And we wanted to make something that could automate these first few steps and speed up the entire workflow. So, speaking of workflows, here's a high-level workflow of how WeaponX works. So WeaponX automates 4 major stages of a pen test style workflow. The first stage being reconnaissance, which in WeaponX is handled almost entirely by ScanCannon. ScanCannon is a tool I'll talk about briefly a little bit later. So ScanCannon uses mass scan to find live hosts and open ports extremely quickly, and then passes those results into Nmap just for deeper service detection, gather more information on what mass scan found. So just a little background on how we found ScanCannon, why we're using ScanCannon. So ScanCannon was created by a guy named Johnny Xmas, who's a well-known security researcher from Chicagoland area. He's worked in basically all aspects of cybersecurity, but he's most well known for his offensive security. He's been a speaker at big conferences like DEF CON, Black Hat. He appeared. This is cool. He appeared in a promotional video for Watch Dogs 2, which I recommend you go check out. He's a pretty funny guy to listen to and very well spoken and very knowledgeable. But he's also the founder of a community called BurpSec, which it's a long-running cybersecurity meetup based in the Chicago suburbs. It's really cool. It brings together everyone from students like me who have no work experience to like CISOs. It's a very cool environment. It's very well known for being like super open. Everyone's super friendly, and everyone's just talking about cybersecurity. It's really cool. It's really unofficial too. Like these meetups are all at like bars that around the Chicagoland. It's not like a big hotel conference, super fancy. Everyone's wearing suits and stuff. It's very laid back, very casual. So Johnny Xmas, well-known security researcher. He's a founder of BurpSec. So at my internship, this girl that I worked with introduced me to BurpSec, and then I just did a whole lot more digging on what the heck this was, who this founder guy is, who is this mysterious Johnny Xmas dude. And then I found out that I actually find him really interesting and really like. I just started listening to a bunch of his stuff, and I found out that he has a tool called ScanCannon, and I was like, that actually is a really good idea. Use mass scan and then just tie it up with Nmap. So then, that's kind of how I was like, beginning of the semester, I was like, I want to use this tool called ScanCannon, and then me and Christian figured out a way to use it. So it's been a fun semester. So the second stage of WeaponX is parsing. So WeaponX reads ScanCannon's output files, extracts IP addresses, ports, and service names, and then builds host and service objects representing each machine. The third stage is action planning, where WeaponX decides what to do next based on the services running on each host. So, for example, HTTP services might map, like a web follow-up action, while SSH is going to try to do some credential testing. So, the last stage is tool execution, where WeaponX automatically runs whatever follow-up commands you've defined for those actions, all of which are very configurable. You could plug in any scripts or any scanners that you want. You could use whatever tools. You don't have to be using the tools that I'm going to be using in the demo later on in this video. So instead of manually reading ScanCannon results and deciding what to run next, WeaponX basically just does that part for us. It does all that automatically. So a quick overview on the architecture. Everything is contained inside a single Python file, main.py. That file is the quarterback that runs our entire workflow. Main.py is basically our Justin Fields. So the tool starts by loading results produced by ScanCannon, which itself, like I previously mentioned, uses mass-scan for fast host discovery and nmap for more detailed service detection. WeaponX reads files from ScanCannon, like a text file full of hosts and ports, interesting servers, to understand which services are alive and which services they're actually running. From there, WeaponX builds host and service objects. These objects store IPs, ports, service names. If ScanCannon didn't label a service, WeaponX uses built-in mapping to automatically assign service names to ports. So, for example, port 22 is obviously going to become SSH, 80 is going to become HTTP, and so on. There's a whole lot of ports out there. Quick time check, hold on. Okay. So, after all the hosts and services are identified, WeaponX creates a per host action plan. This is done using just a simple rules engine. Each service maps to one or more actions, like credential testing or web follow-up for HTTP, or based on defaults or the configuration file that it's looking at. Finally, WeaponX enters the execution phase, where then it runs these tools. It runs whatever external tools are configured to each action. Like I said earlier, all of these are fully customizable. The user can define their own shell commands in a config file, and WeaponX will launch them automatically using Python's subprocess module. So overall, the architecture is very modular and readable. ScanCannon results come in, WeaponX parses them, creates structured host and service data, builds an action plan, and then runs the follow-up commands automatically. So let's dive into a nice demonstration of WeaponX. Oops. Might need to clean things up here. Yes, no spoilers. So, to run ScanCannon, to run WeaponX, you already need ScanCannon results, which we are going to provide in the GitHub for you, just to make things easier, so you don't have to figure out how ScanCannon works to figure out how WeaponX works. So, but running WeaponX is very, very simple. So, you're going to call main.py. You're going to feed in your ScanCannon results. So, WeaponX knows what to do with it. You cannot run WeaponX without ScanCannon results. And then you're going to feed in your configuration file, which is containing all of the word lists. It's containing all the tools that you're going to use in this. All in here. Again, fully customizable. You don't have to use the tools that we're using here. So we're going to hit run. See, we're using Hydra. Again, you don't need to use Hydra. You could use whatever you want, whatever your heart desires. So as you can see here, based on these results, so it loaded one host from the ScanCannon results, 10.0.0.58, had port 21 open. Oh no, so port 21 gets mapped to SSH, and then it gets mapped to the credential testing action. So then now we're running Hydra to brute force using our username and password word lists, which is right here. Take a look at these. So we got a successful hit. We can see that Chandler has a terrible password that was within our word lists. Chandler's gonna need to fix that, but it's too late because we're inside. So that's the live demonstration of ScanCannon working. It's very simple, but also has a whole lot of potential in this tool as well. So we're gonna get into the results here. So for our project results, WeaponX performed, exactly the way we intended it to. First, it was able to successfully parse the ScanCannon output, which wasn't too easy to get working at first. It includes mass-scan's fast host discovery and then nmap's detailed port and service scanning. The tool automatically identified all the discovered hosts, along with the open ports and associated service names. And then after parsing all that, WeaponX created a per-host action plan based on its built-in service-to-action rules. So, for example, if a host had HTTP running, it would have mapped it to a web follow-up action instead of the, wrong window. Instead of, thank God it's still here, the credential testing action, like we saw in the live demonstration. So then WeaponX moved into the tool execution phase where it automatically ran whatever follow-up commands were configured. This is where tools like Hydra or Nitco can be plugged in. Since the workflow is fully customizable, again, you can attach any external command that you want to WeaponX, and it'll automatically run based on the services that it finds. So overall, the project gave us good, strong hands-on experience with parsing, structured scan data, designing automated workflows, integrating command line tools. It also helped us understand the bigger picture of how reconnaissance flows into follow-up enumeration in real-world pen testing workflow. So to conclude things here, WeaponX was a very solid class project that taught us a ton about automation and how different offensive tools can be tied together to create one really cool tool. It helped us understand the full workflow from reconnaissance to exploitation, and gave us real practice, interacting with these tools. So thank you very much for watching. I really hope this was better than my IT-360 video. Smash that like button. Let's hit 150 likes on this video. Subscribe, tell all your friends to subscribe, share it with your family, your extended family, share it with your neighbors, share it with anyone you could think of. Thank you very much for your time. Thank you very much for a great semester. I appreciate everything, and you have a good one.